We are really pleased to welcome Dr Richard Stanton from Cardiff University. Let's get him involved. Hello.
Hi, how you doing?
Hello. Welcome to this evening. So everybody around us, it's the first time that everybody, I feel, has really got involved in science, and they're asking us questions about the coronavirus, and obviously we're not best placed. It's very new to us. So we have got you along to answer our questions. So welcome.
Thank you very much. I'll do my best.
Yeah. So could you tell us, you are a viral immunologist from Cardiff University. What does that mean?
So it means that I spend my days working with viruses in the laboratory, and we spend a lot of our time doing research, and we're trying to work out how do viruses function, how do viruses infect our cells, how are our viruses normally controlled by our immune system, and really we try and understand the interaction between the virus and our immune system, because if we understand that better, hopefully that'll lead to better treatments for some of the diseases that are out there at the moment.
Great. So are you familiar with the coronavirus? Were you familiar? I'm familiar with it now. It's on the news every 10 seconds. But were you familiar with it before?
So it's not the virus that I spend most of my time working on. And you know, that's true for a lot of people around the world. There are a lot of different viruses out there. I work on a group of viruses called the herpes viruses normally. But obviously this has come out now. And so everyone is now suddenly aware of this group of viruses, which have been around for a long time. But in this case, a new one has popped up and caused an outbreak. And so we're now obviously all very interested in this one.
Okay, great. So in this interview, which is going to be about 45 minutes long, we're going to invite questions. I'm still slightly concerned because I haven't got any comments and my staff were primed to just tell me the sound was okay. So bear with me 10 seconds before we go into the... Yeah, it's working, and there's about 14 people watching live, so just no comments yet.
Okay.
Right, let's get the volume of that. So, viral immunologist, we have about 20 questions, so I am going to get started. Our first question, so these have been sent in by our viewers and our friends and things. We're in a lot of schools, it's nearly Science Week, so we're just hearing this chatter. So the first question I'd like to put to you is, why is it called coronavirus?
So a lot of the names of a lot of viruses actually come from the way they look down the microscope. So there is a type of microscope called an electron microscope, and we use these to look at viruses. And if you look at one of these viruses down the electron microscope, it has sort of a ring around it. And that's similar. It looks similar to what we call a corona, like a ring of light around the sun. And so because we call that a corona, then then that is where these viruses get their name from, because of the way they look down the microscope.
Gosh, I did not know that. Lots of things I don't know. Okay, so that's great. Right, hang on. I've just found out why I don't see the comments. Thank you, Grace. Right, so that's fascinating. So it's is my diagram correct-ish?
So kind of, yes. So the way the virus would look is all viruses, in the same way that you have DNA in all your cells, that's your genetic material. All viruses have their genetic material inside them. And in the case of something like a coronavirus, that's surrounded by a protein cage that keeps the DNA safe. And then around all of that, you have a layer of, we call it a lipid. It's like a fat layer. And then stuck in that are proteins that stick out. And it's those proteins that let the virus stick to your cells so that it can then infect your cells. And so what you've got in your little picture there is like the fat layer around the outside and the little proteins sticking out that are going to let this virus stick to your cells and infect you. Okay,
cool. So that's why it's called the coronavirus. What is it? So sometimes we see on the news they call it COVID-19. I'm guessing that's just a shortened version. But what is it exactly?
So COVID-19 is the disease that it causes. And the coronavirus refers to the family of viruses. So there's a whole bunch of viruses in the same family. They're all quite similar to each other. They are called the coronaviruses. This particular one here is called SARS-CoV-2. So that is the particular coronavirus in that family which has caused the current outbreak. And COVID-19 is the disease that it causes.
Right. Okay. So next question. Where do these new diseases come from? So you mentioned SARS, that had its outbreak already. Where do the new ones come from?
So most of these viruses that cause these outbreaks jump into humans from animals. And so we've seen this happen a number of times over the years. We've seen the previous outbreak of SARS. This is a new type of SARS now. We've seen Zika, Ebola. A number of these viruses have come into human populations, and they jump from animals into humans. So some of the previous outbreaks have come from camels or a type of cat. This particular one here we think has probably come from bats. So the virus is normally in bats, and at some point that bat has come into contact with a person, and the virus has jumped from the bat into the person.
Okay, right. So when you talk about diseases mutating, it mutates in the animals and then it's jumped into the humans.
So viruses mutate all the time. Every time a virus goes through a replication cycle, every time it produces more viruses, there is a chance that some of them will mutate a little bit. And occasionally some of those mutations enable the virus to, as well as infecting its normal animal, to jump and infect a new animal. And so in some cases, it might be that it jumps straight from the animal to humans. And in other cases, it might be that it jumps from a bat to a chicken, and then from a chicken into a human. So there's a number of ways these viruses can get to human populations from animals.
Okay. So it could have been going around the bats for ages, and it's not till it mutated that it was then able to... Oh, that's so interesting, isn't it?
Yeah, so we know that bats harbour an awful lot of viruses, and we don't quite know why that is, but bats have a lot of viruses normally, and so they're a good source of new viruses that can jump into humans if they happen to mutate in the right way.
Okay. Right. So I just want to bring it back then to something that people are more familiar with, just to do a little bit of comparison. So we're all familiar with the flu. We probably had it. We know somebody who's had it. We don't have the flu on the news every day. So I just wanted to have a bit of a talk about flu and the comparison to the corona, and talk about the death toll, the death rate, the spread rate, and the symptoms, but just by referring it to flu because that's something people know about already. And I'm going to tell you, I see a lot of misquoted science going around Facebook like crazy, and people will say things like, oh, but flu kills many people a year and we don't worry about that, so therefore we shouldn't worry about corona. So can you let's clear this up. How does it compare to flu?
Okay, so there are differences and there are similarities. So if we start with some of the similarities, we're familiar with the idea that every year the flu virus will start spreading, and it will be spread by people coughing or sneezing, and the virus comes out on little droplets and can spread from one person to the next via those droplets. And in that much, it is quite similar between flu and the coronavirus. It spreads in a very similar way. And in the same way, it's spreading around the world from people to people at the moment. But there are also a number of differences. So if we talk about simply the number of people that are infected or might die from the virus, then the number of people that are infected or dying right now from coronavirus is much, much lower than we see with the flu virus. There are simply fewer people infected, and therefore, no matter how serious that infection is, there are fewer people dying from it. That is a little bit different to the death rate.
Yes.
So the death rate is how serious is the infection if you get it.
Yeah.
And it's a little hard to be exact on that for coronavirus at the moment. The reason being that if you want to know how serious a virus infection is, you have to know how many people had it and got serious disease, and how many people had it and didn't get serious disease. Now, knowing who's had serious disease is fairly straightforward because they go to hospital, they get quarantined, they get looked after. But knowing the number of people that actually didn't have serious symptoms at all is a lot harder because we may simply not know about them. So the estimates we have at the moment are that the current coronavirus causes a bit more serious disease than flu. I think the numbers are for flu, it's about 1 in 1,000 people will get serious disease or may die. For the coronavirus, currently we've seen estimates anywhere from 1%, so 1 in 100, to I think today they said about 3.4%, so a little bit higher. So the numbers at the moment are higher than flu. It's more serious, but those are absolutely a worst case scenario. And we're not going to know the actual rate of serious infection until long after this pandemic is gone, when we can look back and we can see actually who had it and was actually fine, and include those people in our numbers.
Because it's brand new. We can't look at last time what happened, because it is literally brand new. Okay, thank you. Thank you for all your comments. I've now found them. I'm going to talk about death next, Richard.
Okay.
I have a question in about it, and it was the next on my list. So I know we're very keen to not panic people, but when it's science, you've got to talk about everything. So I'll start with the question I've got in. So Mitali says, a country like India having so much population, what is the mortality rate? Is it going to be higher in a third world country, essentially?
Very likely to be, yes. And they have done comparisons looking at different places in China. Obviously, China has the most data so far, because that's where the most infections have been. And certainly even in China, they've seen different rates of death in different cities. And so a lot of that is simply how healthy is your population to start with. The healthier that you are, the more you can cope with an infection. And it's also about how close you are to a hospital, how easily can you get there, how many beds does that hospital have, how much care can they give you. So all these things are going to affect how serious the disease is and what the chances of dying are. So I would imagine that in a third world country, the rate is going to be higher than we would see in this country, for example.
So we were already saying between 1% and 3%. So India could be looking at 3%, whereas somebody like Britain would be on the low. Yes. Obviously, we can't, like we said, we can't say because there's nothing to study.
Yes.
Okay, so staying on death, what does it do to the body? The scientific, let's stay quite scientific. How does it cause death? Oh, let me go on to my next question.
So with all these sort of respiratory viruses, things like flu, things like the coronavirus, what happens is they get into your body through your mouth, your nose, your eyes, and they infect the cells that line those areas of your body. So your skin is a fantastic natural barrier to viruses. Viruses can't really get through your skin, so they get into you through the holes in your skin. So your eyes, your nose, your mouth. Once it gets into there, it's going to infect what we call the epithelial cells. So these are the cells that line the inside of your nose and your mouth. And from there, it's going to spread down into your lungs. Once it gets in your lungs, so viruses are what we call the official definition of a virus is that it's a obligate intracellular parasite. And what that means is that it has to get inside your cells in order to replicate, in order to produce more viruses. And as it does that, it destroys the cells. So the virus gets into the cell, it replicates, it makes loads more viruses, and in the process, it kills the cell off. And so the first thing that happens is it gets into your lungs, it starts infecting the cells there, and that starts killing them off. And clearly that in itself can be quite serious. Your lungs are not going to function particularly well if they're being destroyed in that way. So that in itself can be serious. But what happens then is your immune system recognizes that you've got a virus or you've got something in there that's going wrong. And so your immune system starts sending in immune cells to try and kill off the virus. And one of two things can happen. One thing is the good thing. The immune system kills the virus and you recover and you get better. But the other thing that can happen, particularly if you've got a lot of virus in there, replicating lots, is that the controls on your immune system start going a bit wrong. And effectively, your immune system goes haywire. It starts going hyperactive. It sees danger everywhere. And when that happens, your immune system, instead of just killing off the virus, it will also start damaging the cells in your lung as well. And so at that point, you've got damage in your lungs happening from both the virus and the immune system. And so your lungs are not working well. They can start filling with fluid. And at that point, that's what kills people largely.
Is that pneumonia at that point?
Yes, yeah. So that's pneumonia. That's infection of the lungs. And of course, once you've got this sort of hyperactive immune response, that can then spread around your body and start doing damage in other organs and other places as well. So it can spread from the lungs and cause damage elsewhere. So you get damage from the virus, and if you're unlucky, you also get damage from the immune system, which would normally be getting the virus.
Yeah. Okay, so I'm guessing, correct me, you're the experts. Elderly people we know and vulnerable people, groups of people, are more at risk. I'm guessing this is just because hopefully if I get it, my immune system will kick it out. They have got weakened immune systems.
Yes, and so particularly people who've got any problems with their lungs, for example, that the normal action of your lungs is to, you've got mucus in there, which hopefully the virus is going to get stuck in, and then you've got little wiggly things called cilia on your cells, and those cilia push the mucus up and out of your lungs and your windpipe and things. So the idea is that the virus gets trapped and then it gets expelled from the body. And if you're young and your lungs are functioning well, that's all going to happen properly. If you're older, your immune system is not working well, or you're a smoker, or you're asthmatic, all these things mean your lungs are already not working properly. Your immune system is not working as well, and that's why it's a lot more serious in those people.
Okay, so when people talk about the elderly and vulnerable, usually in a disease, you'd lump children and the young in that. But I've been hearing a lot of that children are not being as badly affected. What do we know about children so far? Are we lumping them with the elderly and vulnerable, or are they separated?
So at the moment, you're right. The data is very much that young children at the moment are not getting anywhere near the same sort of disease that we see in older people. So we quite often assume in the flu, for example, that young people and the very old are both going to be get a bit more serious disease. So far with the coronavirus that we've seen this year, it seems to be the case that young people are really not getting serious disease at all. I think I'm not sure whether this is still the case, but for a little while they were saying that no one under the age of 9 had died from the virus in China. I think that's still the case. And so no one at the moment knows why that is. This is all stuff that's going to happen a long time after the pandemic is finished. There'll be a lot of work done on this kind of thing to understand why that is. At the moment, we just don't know. But it does seem to be the case that it's more mild in very young children.
Okay, so I'm just going to bench the word pandemic, but come back to it.
Oh, sorry. Yes, I shouldn't have said that.
I've just got a couple more questions. So thank you for your questions. I am looking at them. I've had one come in before this video and one come in now. Where do people with asthma stand? But I just want to say, we finished talking about death now. So just in general, what do we think about people with asthma?
So it's really hard for them, and it's obviously potentially quite a scary time for them because they are more at risk from this kind of thing. So they perhaps need to be a little more careful. All I can really say as regards that is to sort of reiterate the standard advice, which is make sure you've got your inhaler with you. Make sure if you need medication for any kind of disease, make sure you're taking it, make sure it's with you at the time. Do your hand washing, do your hand sanitizer, try and avoid people who are coughing and sneezing, keep space from other people that you think might have any kind of infection, really. So it's the standard advice we're giving for everyone, but yeah, obviously people who have things like asthma need to be extra careful because they are more at risk. Yeah.
Okay, and I just imagine, so the picture you gave me of the cilia pushing up is just your body's working extremely hard to eject the virus. Okay, so I hope that helps you, the people who are asking about asthma. So we've kind of covered, I wanted to go into like what it was, what it does. We've got one question that fits in that section before I move on to like how it transmits and how contagious it is. Bivig from North Wales has said, what colour is the virus?
You know, no one has ever asked me what the colour of a virus is.
Wow, there we go.
And I have absolutely no idea because you have to use what's called an electron microscope. I mentioned that earlier on to see these viruses, and they are not in colour. They use electrons to see the virus. So I would, well, yeah, I don't really black and white. I don't really know. That's a good question. I have no idea.
Okay, so just for everybody watching, a normal microscope picks up light, but electron microscope is looking at something completely different, isn't it? So there's no colour involved. So Bivig, I'm sorry, but we don't know for you today. So that's everything I kind of wanted. What were we on? So one important thing before we move on from kind of what is it is there a cure? Would this be called a vaccine? How close are we to one?
Okay, so it's quite a long answer to this one, really. So there's two kind of things you want when it comes to controlling a virus. One is a vaccine and the other is a drug. And they work in slightly different ways. So the idea with the vaccine is that you give the vaccine to someone and that sort of tells their immune system how to control the virus if they are ever infected with the actual virus. That's different to a drug, where the drug you give once you've already got the virus, and the drug interferes with the virus and stops it replicating so it doesn't cause damage, and then your immune system can get rid of it.
Okay, so the vaccine, we'd be taking it en masse without getting it, and then the drug we would take only if we had it.
Yes. And people will be familiar, again, to go back to the flu analogy, people will be familiar with the flu vaccine, which vulnerable people have every year. So the vaccine is about stopping it happening before it starts. The drug is what you give once it's already in you, once you've got it. The short answer is we don't have either at the moment for this virus. The slightly longer answer is, so vaccines, people are working on it. But it's going to be a very long time before we have any vaccines. Minimum would be a year, realistically 1.5 years probably. The reason for that is that we have all the tools to make vaccines, but you can only test a vaccine when people have the disease. And the related problem to that is that developing a vaccine is very expensive. And it's very hard to convince either charities or even big pharmaceutical companies to spend all that money on developing a vaccine if it might never be needed again. So both those reasons mean we don't currently have a vaccine. And then once you try and make a vaccine, you have to go through a large number of clinical trials to make sure that it's safe before you're allowed to put it into people. So there is a company in the States which has just started trials now of a vaccine. But yeah, it'll be a good 1.5 years, I would say, before we know for sure whether it's safe, let alone whether it's effective.
So will the other countries let America just alone doing that, or will all the countries, so China got it, will they be working on it and Britain will be working on it, or will the global community gather together to work on it? How does it work?
So science is pretty collaborative normally. We work together with lots of people from lots of different countries. So I would imagine that the scientists who develop vaccines for other viral diseases anywhere in the world right now will be turning their attention to whether the types of vaccines that they've been developing for other viruses can be altered so that they will now control this virus instead. And so the idea would be you developed a great vaccine against something else, you just switch out one bit of it for a bit of the coronavirus instead, and now potentially you've got a coronavirus vaccine. But the problem then, of course, is you have to test it, make sure it works, and make sure it's safe. Okay. So that's where we are with vaccines. With drugs, again, we don't have anything right now. But what a lot of people are looking at is what's called drug repurposing. So this is where you take a drug which works against a similar virus and you see if it works against this one. And so people have already started testing drugs that we have against similar viruses. Some of those have been tested in labs and it looks like they might work. But again, it's going to take time to get those tested in people, and it'll be a while before we know whether they are going to be effective at controlling this virus in actual people rather than just in a dish in the lab. Okay,
thank you. Right, gosh. But I learned something about vaccine and drugs. I hadn't twigged of the very obvious, now you said it, difference. So now I want to move on to the middle section of our question and answer session today and talk about how it's spreading, what people can do about it spreading, how it spreads, etc. So we know what it is now. Now I want to move on to it spreading. So thank you for your questions, Oshan, Rachel and Andrea. I will get to them in a second. But I'm going to just go to my next question to start this section. How contagious is it? And how does it pass from one person to another?
Okay, so when we talk about how easily a virus spreads, we have what's called the R0 or R0 value. And that value is if one person is infected with the virus, how many other people is it likely that they will infect? Right. And so we talked earlier on about comparisons to flu. I think flu is about 1.3. So every person that is infected infects about 1.3 other people. The best estimates at the moment for coronavirus are that it's a bit higher. It's about 2.2, I think, are the numbers I've seen flying around. So if you are infected with flu, then you're going to infect with coronavirus, about 2.2 people on average. Obviously, that's a huge variation. Some people will infect no one, other people will infect quite a few. But on average, it's a little bit more infectious than the flu for comparison.
Okay, great.
In terms of the way it spreads,
yeah.
So it's effectively, if you have the virus and you cough or you sneeze, the virus comes out of your mouth or your nose in little water droplets, and they will spread the virus to other people. And so those water droplets can sort of stay in the air for about sort of 2 meters around you. And so after 2 meters, they're going to start to drop to the floor.
Sorry, when I sneeze or when I breathe, is it staying in the air?
So I guess if you breathe, it'll be a bit less. If you sneeze, it'll be a bit more. But yeah, sort of we sort of talk about a couple of meters as being the sort of the reasonable distance that this virus or those water droplets are going to spread and carry that virus away from you. So if someone is very close to you when you're breathing or you're sneezing or you're coughing, clearly they can breathe those droplets in and the virus can then infect them. The other way, of course, is those droplets can then drop to the floor, to the surface around you. And we don't exactly know how long the virus is going to stay around on those surfaces for. But currently, people are talking about a couple of days. So 2 to 3 days. So if you're walking around and you sneeze and there's a banister rail there, it might stay on the banister rail for a couple of days. And if someone else comes along and they touch that, they'll get it on their hands. And if they then move their hands to their face, the virus can get into their nose or their mouth that way.
Okay, cool. And I'm a scientist, I have to ask, kissing is going to be bad, yes?
So if you're infected, I would not be kissing someone who is currently infected with coronavirus, not unless you want it yourself.
France, who do the double kiss, have changed, not changed, but they're recommending let's not greet like that. Okay, brilliant. So my next question, I think I can answer this. So if one person in a house gets it, this came in from somebody, does that mean everyone will? So from what you've said, probably, because you're looking after each other and you're going to catch it.
Yeah, so I don't think we have any official figures on anyone who's actually looked at this. But I think if someone in your house has the coronavirus, there's a very, very good chance that it will spread. You'd need to take an awful lot of very careful precautions to make sure that you weren't close to them. And you live in a house with someone, you're going to get within 2 meters of them very regularly. So certainly, if someone in your house has it, I would imagine there's a pretty good chance it's going to spread to other people in the same house. Yes.
Okay, thank you. Right, so I'll move on from that one. This came in from somebody. So we're talking about it spreading. I don't know if this is a stat that's true, but that 80% of the population will get it. I've heard a stat, I know the media is not always correct, but a stat saying 20% of the workforce could be off at once. Why are so many people going to get it? Or are they media exaggeration?
It's not a media exaggeration, but it is absolutely a worst case scenario. This is if it all goes horribly wrong and our quarantine measures completely fail and it spreads unchecked around the population. It's very much a worst case scenario. I would personally be extremely surprised if we saw it get to those kind of numbers. The reason that potentially a lot of people can be infected, we think, is that you don't necessarily have to have symptoms to spread the virus. So we think there are people out there who are infected and they're relatively healthy, and so they're walking around and they're able to infect people. That's a little bit different to what we saw during the last SARS outbreak, for example. People there got very sick very quickly, and so they were very quickly taken to hospital. Having said all that, of course, we've seen in China, they have implemented very strict quarantine, and that seems to have worked quite well. So in China at the moment, things seem to be calming down quite a lot. And that started happening when they enacted very strict quarantine. So I think if it gets bad here, they will enact probably similar quarantine measures. And it seems from China that will work to restrict the spread of the virus. So I think it's a very much a worst case scenario. I'd be really surprised if we saw that happening.
those numbers.
Yeah.
So Rachel Mason, again from North Wales, has just a related question. How does it burn out? So you're saying in China it is slowing down.
Yes.
But what is going to stop this virus? What's going and spreading?
So a big thing when you have a new outbreak like this is that no one's immune systems have seen this virus before. So that means everyone is susceptible to being infected by this virus. So what's going to happen over time is that people will have been infected. They will have immune systems that now recognize the virus and can control it and can kill it. And so that will limit the spread of the virus, even outside any sort of quarantine measures that countries put in place.
Okay. So I want to talk about animals again. So we know it came from animals.
Mm-hmm.
Are animals still spreading it?
So I think there's only been one report so far, although it was quite widely reported, of an animal being infected with this virus. That report was of a dog, which tested positive for the virus. But there's absolutely no evidence at the moment that animals are becoming widely infected by it. And there's certainly no evidence of animals spreading it. Even that one dog there, what they're saying at the moment is they haven't confirmed that it was infected. And if it was infected, it was a very mild case. So I really think that's not something to be concerned about at the moment. The usual rules apply. You know, if you're sticking your hands all over your animals, give them a wash every now and again. But there's no particular reason to be concerned about animal spread of this virus.
Yeah. So a viewer has said, Oshan, could you use a vaccine on an animal? But I think we're saying we haven't really found enough that would be necessary yet.
No. So there are, in terms of research going on worldwide for viral diseases generally, there is a lot of interest in rather than reacting to these pandemics when they jump from animals to humans, could we cut them off at the source and start vaccinating the animals so they then can't spread the virus to us. So that's not going on for this virus because we've only really just found out about it. We've only just found that it's dangerous and it can affect humans and all that kind of stuff. But more generally, in terms of the scientific research going on for virus diseases in general, people are looking at doing this.
Okay, thank you. Technical error here. Right. Next question then. So let's start talking about advice.
Okay.
So, obviously you're not putting your name behind this, but do you have any advice on how we can protect ourselves?
So really all I can do is give out the official advice that governments all around the world have been giving out, which is if you think you might have it, call 111 in the UK. Don't go to your GP surgery because, of course, then you might infect other people. Call that phone number and they can give you the right advice to take if you think you might have it. Quarantine yourself so you don't spread it to other people. And really the best thing you can do when you're out and about is hand washing is probably the best way of making sure your hands are clean. And as we said earlier on when we were talking about how the virus transmits, a very common way for the virus to transmit is for you to get it on your hands and for you then to touch your face and transmit the virus into your mouth or your nose that way.
We said banisters, escalators, lights.
Yeah, all those kinds of things are potential sources where you can catch it. And people have done studies looking at how much people touch their faces, and you'd be amazed how often people touch their faces without even thinking about it. We're doing it all the time.
I'm noticing myself stroke my fringe back. So
yeah, exactly. Yeah, so it's really common. And so you want to be washing your hands if you can. Hand washing is the best thing of all because you're getting rid of this virus, you're getting rid of other viruses, bacteria, you're getting rid of the dirt that might otherwise trap viruses on there. So that's best. Of course, that's not always practical. And so the next best thing are the hand sanitizers that you can get. And if you're going to use hand sanitizers, the best thing to use is, or you have to use one that's got ethanol in it. So, yeah, the important point is they need to have, I think, 60% ethanol is the minimum. So if as long as they have more than 60% ethanol, then they will kill viruses like this very well. They won't kill all viruses. So I talked earlier on about the structure of the virus, and I said it's got this layer of fat around the outside. It's that layer of fat that is destroyed by the ethanol. Not all viruses have that, and so not all viruses are destroyed by ethanol, but this one does and is. So the hand sanitizer is a good second option.
Okay.
And of course, sorry?
That was one of our questions.
Yeah.
Why would hand sanitizer kill it if it's a virus, not a bacteria?
Yeah, so it's all about basically, so I said that stuck into that fat layer, you have these proteins that let the virus stick to your cells. And so if you strip off that layer of fat, the proteins disappear and then the virus can't stick to your cells anymore. It's exactly the same reason that washing your hands is good too, because the soap in there strips off that fat layer and stops the virus being able to attach and infect your cells.
Okay, right, Richard, let me just take a breath and just look at, thank you so much everybody for your questions. I have a thread of where I'm going and I'm weaving them in, but do keep them coming because I may put them in where they fit with our thread. So let me just look at these. So travel questions, somebody's going to watch it later. Here's a good one. So on the topic we're talking about, I think we did kind of cover this earlier, but how long can the virus survive on a surface? Did we say we didn't know yet?
Well, so we don't know exactly, and it depends on the surface. So the current estimates are, if you're thinking of things like escalator handrails, that kind of thing, we're talking 2 to 3 days. So after 3 days, it's going to be a bit more dead, pretty dead. But not every surface is the same. So fabric, for example, the virus does not survive well, or viruses generally don't survive well on fabrics. And also the weather affects things as well. The more sunny it is, the more quickly those viruses break down when they're outside. So there's a large number of factors that affect how long that virus survives. The temperature, the humidity of the air, all these things change how long it survives. But if we're talking ballpark figures, 2 to 3 days is sort of where we are.
2 to 3 days.
Yeah.
Right. Okay. Brilliant. So this is a personal question now. My daughter doesn't use soap because she's got eczema.
Okay.
She said to me, Mummy, could you buy me some soap? Washing with water, is she okay, or should we be investing in soap? So
washing with water is not going to be anywhere near as good as using something like a soap or a hand sanitizer. And it comes back to you want to strip this layer of fat off the virus. And so it's that action that gets rid of it, and water alone is not going to do that. Okay. So I don't know exactly what things you can use if you've got eczema, but I definitely look into what things you can use other than just water.
And it's weighing up the risks, isn't it? It's like eczema is not as important right now.
Yes.
Okay, thank you. So Wendy has said, I heard you can use vodka.
I'm not sure if she means to drink it or to
wash her hands, hopefully.
Okay. So I don't know what percentage vodka is, but it comes.
60%. It's got to be more than.
Yeah. So if it's more than 60%, then I'm sure you can. It's quite an expensive way to wash your hands, but go ahead if that's what you've got and it's more than 60%.
Okay. Right. Let's see what the next question on my list is. Oh, we've covered that actually. So that's the hand sanitizers do work, and we've clarified
they work as long as they have ethanol in them. Yes.
Ethanol. I put that in the comments as well. So more than 60% ethanol.
Yeah.
Right. So now I've got a gender question. So is there any reason why men or women are more or less susceptible? So we know aren't at the moment. Elderly are susceptible. Men or women?
So I'm not aware that there's any evidence at the moment that there's a difference between them. I haven't seen that. So I couldn't comment on that, I'm afraid. Sorry.
Okay. And I'm sure we've covered this, but I've got questions about soap. We said soap was okay, didn't? Because that breaks down the.
Soap's good. So soap's best of all is better than hand sanitizer in many ways, because it acts on all viruses and it washes them off, it inactivates them, and it gets rid of the dirt as well. So yeah, soap is best of all.
Yeah, and it's cheering to me that the weather change might have an effect as well.
Yeah, it may not. We're just gonna have to wait and see. Certainly, we think that one of the reasons why flu keep coming back to flu, I know, but one of the reasons why flu goes away a bit in the summer is that the virus does not survive, or the virus survives better if the air is cold and dry. And so that's the reason why some people have suggested that we might see a reduction in cases from this virus in the summer as well. But until that warm weather gets here, we're simply not going to know whether that is the case or not. It may be, it may not be. Okay.
So that brings me, so we've kind of talked about everything, what it is, how it passes, how we can prevent that passing. One more question on that. People are desperate to know, we saw this in the questions sent in, the questions tonight, travel. Should we be traveling?
So again, all I can really do here is reiterate the official advice that the government has given out. They have listed countries by category. I think there are 3 categories out there now for countries that you really shouldn't travel to. Obviously, China is one of them. South Korea is another. I think, I'm not sure which category Italy is in. And then there is the category of countries which have outbreaks, and so you probably shouldn't travel to unless it's really important. And then everywhere else, which at the moment is okay. So check the government website there, see which category that your country falls into, and use that to guide your decision as to whether you travel there or not.
Yeah, so what the guides are saying and how important what you're doing is. Okay. So we haven't touched on this at all. So somebody said, is there anything extra things you could consider if you're in an airport? And I was just thinking, we haven't covered face masks.
Oh yeah.
Obviously, if we do decide to travel, we'd be hand washing, we'd be staying away from people. What about face masks?
So the evidence there is they are not really going to do very much. The one place where a face mask might do something is if you yourself are infected. And then as you're coughing and sneezing, the face mask is going to catch those droplets and stop them spreading to other people. So potentially, if you are infected, then the face mask might do a little bit of good. But if you are trying to prevent yourself getting infected from other people, then really the evidence is that they're not very good at all. The reason being they have lots of gaps around the edge of them where the virus can still get in. And as you breathe in and out of them, they get wet. And once they're wet, they're less effective. And of course, if everyone runs out and buys these face masks, then the people that really need them, the doctors, the nurses, who don't wear them, they aren't wearing them to stop themselves getting infected with this virus. They're wearing them to stop themselves getting splashes of on themselves when they're dealing with patients. They won't be enough for them. So I would definitely not advise wearing a face mask. It's not going to do you much good. And if everyone does it, the people who really need them are not going to have them.
Okay, thank you. Right, so I think the comments must be coming in batches because there's like 20 and then none and then 20. Right, so I would really like to move on to where we're going with this, what's going to happen in our communities and things like that. So where shall I start? I've got one here from Steve Tro. Let's just finish with that one. So is it possible to catch the virus again once you've fully recovered? Because that's really going to affect how it spreads, isn't it?
Yeah, so generally we think that is probably not the case. So there have been sort of sporadic reports coming out where people have suggested this might have happened, but actually there is no good evidence for that at all. What we think is more likely the case in those scenarios is that someone had the virus, they started to get better, the virus started to be controlled a little bit, and then for whatever reason, that control was lost and the same virus came back a little bit again. So generally with viruses like this, we would say once you've had it once, you have survived and the virus has gone, you now have an immune system that knows how to control that virus. And so you shouldn't then get a second infection.
Okay. So another question here from Zoe Bailey. Can the virus mutate? And if so, how quickly? So my understanding, again, from reading media, which is not the best source, but it has already mutated. We're on the second.
So there's a little bit of controversy around that. Well, not around the fact that it has mutated. but around the fact or what the consequences of that mutation are. So I said earlier on that all viruses mutate when they replicate, and that's part of how they jump from one species into another, like from bats to humans. And people have been furiously sequencing the viruses that have been infecting people all around the world. And there are some differences between those viruses, like a single nucleotide changes, which are mutations. So the virus is mutating a little bit as it transmits. And that is something that all viruses do all the time. We absolutely expect to see that happen. So there has been a report that there are definitely 2 strains circulating in China. And there has been a suggestion that because one of them has been recovered from more people, that means it's a bit more dangerous or a bit more virulent. The problem is, of course, there is what we call sampling bias. So you sample more from certain places than others, where you think the disease might be a bit more serious. And if you are sampling from different places with different intensities, you will recover different viruses in different amounts. And it doesn't necessarily mean that one is more infectious than the other.
Yeah.
So
we discussed already, didn't we? It's a live situation, so there's just not enough. You just can't get an equal spread of data.
Yeah, there's an awful lot of things that we're simply not going to know until long after this has all died down. So the virus absolutely does mutate, but we don't yet know what the consequences of that might be.
Yeah, and how quickly we're not sure
Yeah.
yet. Okay, thank you. Right, so we've covered a lot of them. So how is it going to end? Like, what do you envisage? So I envisage in a couple of weeks the schools will start closing in Britain, because we've seen that in other countries. I'm imagining a summer where the festivals are closed. How long could it go on, and how could it end? I don't know what with the apocalypse. I'm thinking like a more happier end.
Yeah, not with zombies, hopefully. So there's a few scenarios, and of course we at this stage we simply don't know which of these is true. But it seems likely at this stage we're going to see more cases in the UK. All countries where this virus has had cases have seen those cases increase. At the moment, we're talking about a doubling about every 5 days in most countries, and that seems to be fairly consistent. So the virus now, I think, is pretty well within the UK, and we're going to see more cases coming out.
You know what today's figure was?
I think it's 115, I think today was the figure.
Saying a doubling every 5 days.
Yes.
So 200 by next week, and then by April talking 400. Then
roughly speaking, yes. And if that, if that carries on, then we may well see measures such as those that have been brought in other countries, where we see progressive increases in the restrictions of people's movements, trying to stop people gathering together in large places where they might transmit the virus between each other. So that may well happen.
Yeah, and you said China, it is on the it's steadied out, hasn't it now? So
so it looks as though things are dying out in China now, and that seemed to start happening when they started introducing the quarantine measures. So there is hope that that is a successful and sensible approach to stopping the spread of the virus if it starts getting worse.
So, but once they stop quarantining, like they open up the schools again, will it not just kick off at the same speed again?
So it may not. So if a certain number of people are infected and their immune systems now can recognize it, that will limit the spread. And the two sort of longer term scenarios that we're looking at are, one is that this is on relatively speaking a flash in the pan. So it happens, lots of people get infected, and then eventually it dies out and disappears again. So we saw that on a much smaller scale with SARS and with MERS in previous years. There was Zika virus last year or the year before. We saw a big outbreak with that, and then it all sort of calmed down and went away again. And so it may well be that that happens with this virus. The alternative is that actually this virus is here to stay, and we're going to start seeing infections with it potentially every winter in a similar way to what we do with the flu virus. And there are plenty of examples of other viruses that we think of today as normal human viruses, which originally were in animals and jumped into us and have now stayed with us as a human virus. So either of those scenarios is perfectly plausible at the moment.
So do you think or can you guesstimate? Do you think there's going to be a point where the British schools will shut? Or I work. We do science shows in schools, so we know Dublin is shut at the moment. Do you think it's coming over to us?
So this is purely a personal opinion. Obviously, this is not based on any evidence at all, really. But my personal opinion is that it seems to be in most countries where the virus has started spreading, the quarantine measures have slowed it down, but they haven't stopped it. And really, it's those more severe quarantine measures that Italy has brought in, that China brought in. Those have been required to really put the brakes on the virus. So I certainly wouldn't be surprised if it happens. I don't know for sure either way, of course, but it wouldn't surprise me if that happens at some point down the line.
But you're set. That's good though, because I sometimes, so somebody's asked on the thread, should we be worried? As a scientist, I don't go about my daily business worried and panicked, and I sometimes think, oh, they're overreacting. But you're saying that by shutting the schools in China and Italy, they have curbed their spread, so that it would be a good thing to do, not because we're panicking, but just to get that downtrend.
Yeah, I certainly, in science, we're very cautious about saying things definitely happened because of a certain reason.
Yeah.
But certainly, it seems to be the case that the drop off in China has correlated with those extreme restrictions. And so, if that is because of the restrictions, then the same thing would probably be true here. So, yes, it would be a sensible precaution to take, and there is reason to think that it would work quite well.
Okay, so just to go over Zoe's comment, should we be worried? Now, I just want to, before you go into this, just reiterate that we could all get it, but there's going to be that low death. Some people are going to die, but there's not going to be 980 in every 1,000 that are going to survive, isn't there? So I'm worried. I've said that. What about you, Richard?
So no, I'm definitely not worried. I think we need to sort of hit the right pitch with this. It's not nothing. This is not nothing to be worried about at all. It is a virus which is going to spread, and it will cause serious disease in some people. And people who are old, who have underlying health conditions, are at quite serious risk. We need to be realistic about that, and we need to take the advice that we've been given seriously about self-quarantining if we're ill, about hand washing. One thing I haven't said, of course, is that you should get your flu vaccine if you are eligible for it, not because it will protect against coronavirus, but because we don't want people to be getting coronavirus and flu at the same time. It could make one much worse. So I'm not personally particularly worried about myself or my family, but we need to be realistic. It is a serious situation, and we should be serious about it and take precautions, but I'm not particularly worried. If that sort of hits the right point and answers your question. Yeah.
Okay. So I'm at the end of my questions. I've got a few good ones in. All over which one? So we talked about schools shutting. So Ollie Stanton is saying, is it likely that we have travel bans by the summer? So
we've already seen travel bans in some countries. So China, well, not travel bans, but the government is saying really do not travel to these places. And if the virus continues to spread in the same way, and we see large outbreaks in other countries, then that advice is going to be don't travel to those countries either. So yeah, we may see other countries where the government is advising us not to travel to because of the scale of the outbreak there.
Yeah. Okay, just one comment from Zoe. So she's saying she's not worried. However, do know a few family members with very low immune systems are worried. Yeah, sorry, Zoe. When I didn't mean to sound not empathetic for them, but I'm talking about I'm not worried about a global apocalypse kind of thing. But yes, obviously the people who are vulnerable, it is worrying for them. Yeah.
Yeah, absolutely. I can only reiterate that. Yes, there are definitely people who are at very high risk, and this will be a very concerning time for them. And really, all I can say is the rest of us should take the advice we've been given seriously, because the best thing we can do is try and make sure the virus doesn't spread to those people who are more vulnerable.
Yeah, and that would be by washing our hands before we go and see our relatives. If we've got colds and coughs, staying well clear.
Yes.
Okay, great. So somebody else, this is quite interesting. if it's here to stay, so we've talked about various scenarios. It could be flash in the pan, or it could be here to be another flu. Will the measures be the same in the following years? So I'm guessing they mean the measures of the travel bans, the school shutting.
So again, I don't know. If I had to venture an opinion, I would say it will not be as extreme in subsequent years. Primarily, so the big thing with flu is that the flu changes every year. And that means that you may have developed immunity in 1 year from the virus that you caught, but that won't necessarily protect you against the flu that comes along the next year, because there are differences between them. That doesn't, the reason that the flu can do that doesn't apply to this virus. So it will mutate a little bit, because that's what viruses do. But probably if you are infected this year and you get immunity to it, that's going to provide you with at least some protection next year. So we should see in subsequent years, I would guess, that it will be less severe, because people will have some existing immunity to this virus.
Okay. And on that note, it's not going to go on forever, like you're saying. So that is going to mean it dies out naturally. So even if everybody got it, we didn't wash our hands, it will then. I think of dominoes. It's like they keep going, but then you're suddenly inserting white ones where people have had it before, and then it can't.
Yeah. So, well, yes and no. So, you think of things like the common cold. So, the common cold, people will get it, they'll get immunity to it, but the virus doesn't go away completely. And there are a number of reasons for that. One of which is that the virus can change a little bit. One of which is that our immune system doesn't always have a sort of perfect memory. And so over time, that memory can fade. And so after a few years, you then become potentially susceptible to being infected again. So we may not see, we will probably see it, I would guess, we will see it being less severe, but it may not necessarily go away completely.
Okay, thank you. So I know we've covered this, but Steve Tro says, are we close to a vaccine? Steve, Richard said it was about 18 months.
Minimum.
Minimum, yeah. So, yeah, no is the answer to that. Right, thank you very much, Dr. Richard Stanton. We are nearing the 60-minute mark. So what I am going to do is just finish us off, and then I'm just going to scroll if there's any other questions, and then we can shut it down, because it's been a long 6 minutes, but it has been absolutely fascinating. Thank you very much.
That's all right. Thank you very much.
Is there anything you think we've missed?
I don't think so. No, I think we've covered all the major points. Yeah.
So we will add down below the link to the how to stop it spreading. What website did you say that was?
I've forgotten now. I looked it up before. It's the government Commonwealth. I can't remember. Sorry.
That's all right. We will get you all these links and put them down below, and also the travel, where you should travel. That's on a government website. But we recommend everybody follows the advice, and yeah, hopefully it will become contained. So one more question from Zoe. I can't resist, because she's commented, when do we think it will peak? What do you think, Richard?
Oh, blimey. I really don't know. I'm trying to think how long since we had, really the best data we have is from China, because that's where it started. That's where they had the most amount of cases. And there, I'm trying to think back how long it was from when the first case happened to sort of the peak there. I think it was a few months.
Yeah, about 2 months, isn't it? Because if we're staying steady now, it went whoop, and then
yeah. So I mean, we would hope, I guess, that it's controlled a bit better here, because we've got a head start. China didn't know this was coming. It took them a while to realize what was going on. We have the benefit of their experience to work from, so hopefully it will be better here, but that's the information we have to go on at the moment, really.
Okay. Right, well, thank you for everybody who sent in questions. We would love it if you could share. This will take a while to upload now, but then this video is a full guide, a comprehensive guide with all Richard's genius for full minutes. So feel free to come back to our page and tag people who are interested in the coronavirus, or you can send the link to your schools if you wanted to watch it in your classes. And thank you very much for your time this evening, and everybody who's been with us for the last hour. I'm sorry if I've missed any questions. It's quite complex to find all the questions. I will probably go through the questions now and just direct you, because we did cover some of them earlier in the hour. So some of you asking questions who joined us later, you'll be able to find them earlier on. Thank you very much, Richard. If you could just stay on the line, that would be great.
Okay.
I'm going to, somebody else from my company is putting the links. That's amazing. Thank you. I'm going to stop it now, but if you could stay on the line, we can just have a chat. But bye-bye, everybody out there in Facebook land. And,
bye.
and thank you very much.